Let us take one more example, that is, design a joint of an angle section ISA 90 by 90 by 8 mm of FE 410 grade when welded to a 8 mm gusset plate on all the three sides as shown in the figure. So here the figure is been given, the section is mentioned here, and for this we need to design weld here. So here this is the section given 90 by 90 by 8 mm, and this is the gusset plate. For this gusset plate, this section is joining, and this section is been joining through a weld, and the weld is been applied on three sides. This is 1, 2 and 3 sides the weld is been applying, and for this load P we need to design the weld size as well as the length of the weld required here. So in this figure they have clearly mentioned, let L1, L2 and L3 are the effective length of weld. So here they have mentioned this side length L1, this side they taken length L2 and this side L3. We don't know this L1, L2 and L3. We need to calculate those lengths. And also the load P is given here. Load P is given, that is to be calculated because the load is not mentioned here, but we need to calculate this load P. To transfer this P, what is the length of weld required? So initially we are assuming this side length L1, this side length L2 and this side length L3. You may take in any order, either you may take this side L1, this side L3 and this side L2. So any order you may take. So here we are assuming this side L1, this side L2 and this side L3. Corresponding to this length L1, the load transferring by this side will be P1. Corresponding to length L2, the load transferring by the L2 will be P2. Corresponding to load L3, length L3, the load transferring by L3 will be P3. Okay. Then next the P will be P1 plus P2 plus P3. Okay. So this is the things. These are the things we need to mark initially, and this is the section. And this gusset plate, for the gusset plate the angle section is joined, and here the weld is been applied and here the weld is been applied. There is a fillet weld, and this is the angle section given, and mark the CZ of the section, that is CXX, and this CXX you have to get from the steel table. Then next, here they given clearly, since the load is not given, joint is designed for full strength of the member. Here the load is not given, the joint is designed for the full strength of the member. Very, very important here. From the steel table or IS handbook, note down the properties of this section, that is 90 by 90 by 8 mm. So from the steel table we have taken the area of the section, then you take the CZ of the section, that is CXX. So here it is given CZZ, it is not a CZZ, you just make a correction, that is CXX, that is CXX. Then after this, calculate the tensile capacity of the member, that is full strength of the member, by using this formula. Then in this formula, where AZ represents gross area of the connected member, then Fi is the yield stress of the member, then gamma MO is the partial safety factor for the material, that is 1.1, then Fi is 250. Substitute all, you will be getting the tensile capacity of the member. So this is the actual load which is being acting. For this load, what is the length of the weld required? Then after getting this one, then we have to get the size of the weld. To get the size of the weld, so again we know the procedure. Initially we need to take the minimum size, referring table number 21 IS 800 2007 page 78 and 79. Then we have to get the maximum size based on the edge conditions. Once we get minimum and maximum, so in between the size of the weld to be taken. So here the size of the weld is been taken as 6 mm. So we have a minimum size and we have a maximum size. So in between the size of the weld to be selecting, then here we have selected size of the weld as 6 mm. Then calculate the effective throat thickness. Then after calculating the effective throat thickness, calculate the design strength of the weld. So in this we don't know the length of the weld, that is the unknown. Keep as it is. Then the rest all things to be substituted in this formula. Then we get the design strength of weld in terms of LW, that is the unknown. Once we get this design strength of the weld, then equate this to the this one, that is equating the strength of the weld equal to the strength of the member. Here they equated. Then you will be getting the length of the weld. Then this length of the weld is equal to L1 plus L2 plus L3. So since the section is connecting like this, I'll show you. So since the section will be like this, sorry, like this, which is connecting to the gusset plate, and we know this side is 90 already, we know. Okay, so this side we have marked as a L2, hence the L2 length will become 90 mm. Here they have taken 90 mm. I hope you understood. This side section length or width is 90. So hence the length L2 we can easily known. So that is L2 equal to 90 mm. Then once we get a L2 equal to 90, just we have to get L1 and L3 taking moments of forces and P1, P2, P3 and P about a section 1, 1. So to get this L1 and L2, because we know length L2 and this L3 and L1 are the unknown, and these are the corresponding forces, that is P1, P2, P3 are the corresponding forces. We have to take the moment about the centroid, about this one. So once we take the moment about this centroid, we will be getting L1 and L3. Here they are taken. P into 25.1 is equal to P1 into 0, because P1 section 1, 1. So here they are taken this as a section. I'll mention here. They are taking this section 1, 1, because about this they are taking a moment. So this P1 is passing through the moment center, P1 into 0, then you have to take a P3 into this one, then P2 into this one. Here they taken P into 25.1 is equal to P1 into 0 plus P2 into 90 by 2 plus P3 into 90. Just you take moment about that section, you will be getting this equation. Then after that one, you will be getting this one. P2 you will be getting P2, that is this much you will be getting in terms of L2. Then also you will be getting a P3 in terms of L3. Then you have to equate. Again you will be having the equation as given above. So this you substitute these all things here. So after substituting you will be getting a L3 value. Just to solve it, you will be getting a L3. Then LW equal to what? LW equal to L1 plus L2 plus L3. Then in this Out of this you will be knowing L2 and L3, then you can easily get the L1. Then uh, write L1, L2 and L3, and same you marked on a figure here. So this is the procedure how to calculate or how to design the weld for all the three sides for the given load, or if the load is not given, we have to get that load for the full strength of the member by having the formula. So then once we get the load, for that load we need to design the length of the weld. This is one more important problem. So please practice this kind of problems and uh, solve it. And here one more problem is been given here. Uh, so please take it as an assignment and please practice this problem. Thank you.